Hi guys, grade 12s, welcome to Learn Extra Saturday School, and this is especially for you. I'm Indy and this is Tamlin.
Hi there.
And we'll be doing maths today with you guys. So I hear, Tam, we're doing paper 1, right?
Paper 1, is that? Yes, that's today.
Yeah, and what are the subjects that we'll be talking about?
Or
the topics,
yeah,
rather.
The sections in paper 1, we're looking at sequences and series, calculus, we're looking at financial maths, and
yeah. And guys, you know what's really important today and really exciting is that if you guys call in to the studio, we're actually going to be giving away winter school guides, which is maths, which is going to be very cool, and it's going to be able to help you through winter school. It's got all kinds of exercises that you can follow along during the shows in winter school that will be starting in July. And we'll also be giving away any other book of your choice, so whether it's maths, literacy, geography, life science, you let us know. But get chatting to us on the page, and if you want to go and take a spot by your board.
I will do that.
Yeah, so guys, let me do my normal preamble. Chat to us on Facebook, facebook.com/learnextra. Also chat to me on Twitter @learnextra. Let's get learning more and let's get learning extra. Now is the time to get all of those questions in that have been burning and you've been needing to know. And we'll also be taking in the last 15-20 minutes of the show any of your questions that you may have, as well as the live callers. I'm just about to post on the Facebook page that number, and if you call in with your question, you will be getting a free winter school book of your choice too. Let me give you that number. It's 086 105 8262. And without further ado, let's start our lesson.
Thank you, Indy.
Such a pleasure.
Right, one of the big sections of our paper 1 we're going to be looking at is sequences and series. It's a section that you will be getting your formulas on your formula sheet, so that's always going to be nice to have. But obviously we need to be very familiar with them, and obviously we need to know how to apply them. Right, so let's have a look at our first question over here today, which is going to be, we've got an arithmetic sequence. Okay, we've got -10, -3, 4, and 11. And what they're first of all asking us to do is to determine the value of the 50th term. Okay, we are not expected to sit there and write all 50 terms out. We're going to use our formula to work it out. Okay, because they've told us it's arithmetic, we automatically know that we're working with a common difference. Okay, so first things first, let's work out what our common difference is actually going to be, and we're going to do that by saying term 2 minus our term 1, and that's got to be equal to term 3 minus term 2. All right? If we take term 2, which is -3, and I minus term 1, which is -10, you see we've got the two negatives next to each other over there. That's got to be equal to term 3 minus term 2, which once again will have two negatives. So what have we got over here? We've got -3, that's going to land up being plus 10, and over here we've got 4 plus 3, so do we see that our common difference in this particular series is going to be 7. Okay, now that we've got that, let's let's first of all write down our formula. We've got our Tn is equal to a plus n minus 1 d. That's our Tn formula for our arithmetic sequences. Okay, what do we know? The a represents your first term in the sequence. The n, remember, that represents the position of the term in the sequence. Okay, so we're looking for the 50th term, so that would be our n. And, okay, so let's just write that's our position. And our d over here, that's going to represent the common difference. Okay, so our common difference. Okay. So, knowing that, let's fill in what we have. Let's take this away for a moment. Okay, we've got T50. We are trying to find our 50th term. And into the formula, we've got A, the first term of our sequence we knew was -10, plus n minus 1, 50 minus 1, and then multiplied by our common difference, which we know is 7. Okay, so having done that, we've got -10, and I've got 49 multiplied by 7, and 49 multiplied by 7, I need to get our calculator.
Oh, Let me have a look. I think I might even have a calculator. Maybe I can do it for you.
Thank
What did you say? 40?
49 times 7.
49 times 7 is 343.
343. Right, so we've got negative 10, and we've got 343, and when we subtract 10 from 343, we land up with 333. Right, so the 50th term in that sequence landed up equaling 333. Okay, right, so now that we've done that, they're now going on to say, with the same sequence, we want to take how many terms added up to 3,152. Indy, please stay tuned because I'm going to have to need that calculator.
That's okay. You just let me know. I'm on the ball.
Okay, right. We're looking for the sum of. Okay, we're not working with the Tn formula anymore. We're now working with our Sn formula. Okay, let's quickly write it down. Our Sn formula for arithmetic, we know that it's arithmetic, is going to be n over 2. I've got 2a plus, and we've got n minus 1d. Okay? Once again, our a still represents our first term. The n still represents the position, which in this case is what we are trying to work out. We need to know how many terms actually added up to our 3,152. Okay? Our common difference, which we worked out earlier, was 7, still's there. Okay? So we're looking for 3,152 as the sum of our terms. We've got n over 2 multiplied by 2 times the first term, which is negative 10. Once again, n we do not know, but we know that our common difference is going to be 7. Okay. Right, now that we've done that, we need to find the best way to simplify this out. If you're sitting with this n over 2 that's being multiplied to that whole bracket over there, because it's being multiplied, you are allowed to take the 2 from down below, and you are allowed to multiply it up on the other side. Okay, so we're going to take 3,152, Indy, thanks.
3,152.
That gives us 6,000.
Times by 2 gives you 6,304.
6,304. And on this side over here, let's just simplify out the bracket. We've got negative 20. I'm going to distribute my 7 into the bracket over here, so we will have 7n minus 7. Okay, and let's just quickly do one more step of simplifying. Negative, that's going to work out to be negative 27, and we have got 7n. Okay? Next step, we're going to have to distribute that n. So we've got 6,304. I've got negative 27n, and I have got 7n squared. Do we all see where we're going with this? Okay, it's going to be a quadratic equation. We're going to have to solve for n as a quadratic equation. So, rules of quadratic equations. Let's gather everything to the one side of our equal sign, and we want the other side to be equal to 0. Okay? So, keeping my n squared as positive, I'm going to gather everything on the right-hand side over here. And I'm going to have 27n, and we've got negative 6,304. Okay. This now gives us the opportunity to practice a little bit of the quadratic formula. Okay, we've got a trinomial over here that we're going to factorize. Big numbers like 6,304, let's just use our quadratic formula instead of trying to work out all the factors of 6,304. So, to work out our values for n, we are going to take negative b plus minus the square root of b squared minus 4ac, and it is all over 2a. All right? With that, remember the value in front of your n squared is your a value. The number in front of your n is your b value, and then the constant term at the end, that is your c value. Okay? Just to bring it to your attention, that c value has got a negative in front of it. So when we substitute it into the formula, that negative must go with it. Okay? Right, so we've got negative. My b is a negative 27. I've got plus minus the square root. We're going to have our negative 27 squared minus 4. My a value is a 7. And my c value is a negative 6,304. Let's just make that a bit longer. And what we now will have is all over 2 times by a, which was 7. Sorry, Indy, I'm making you work on the calculator
No,
today.
don't worry. What was it again?
Right, so we've got 27, positive 27, plus the square root of, okay,
I fear I don't have a mathematical calculator. Have a look at your tabs at the bottom and let's have a look. Does it say at the bottom their calculator? No, it doesn't.
All right, well, grade 12, you substitute this into your calculator over here, and we're going to land up with 2 answers for n, okay? I'm going to tell you that the one answer for n should be 32, okay? The other answer for n that we get works out to be quite a big irrational number. It works out as a non-terminating decimal, okay? Now, when we're solving for the position of when we're solving for the number of terms that we're adding up together, you cannot add together. The position of your terms cannot be anything other than a natural number. So for the 2 values for n that you found on your calculators, because I know you all sat now and done it yourselves, we've landed up with 2 answers for n. The one of them worked out to be 32, and the other one was a number. It was a decimal value, okay? The decimal is the one that we do not want. We do not add up the decimal. How many terms added up to our original question was? How many terms added up to 3,152? 32 terms. Added up to 3,152. Okay, all right. So I hope you all got that on your calculators. And let's have a look at another question. Right. We've got another arithmetic series. When you're reading a question paper, one thing to just watch out for is make sure that if they've stated it's arithmetic or geometric, that's great. Then you know exactly which direction you need to go in. If they haven't specified, then you need to do a little test for yourself. The test to see whether it's arithmetic is to check whether your term 2 minus term 1 was the same as your term 3 minus term 2. If it's not the same, then you need to check if it's geometric. All right, your geometric test, term 2 over term 1 had to be the same as term 3 over term 2. And remember, that is what we call our common ratio. Okay. However, in this case, again, we've specified that it's arithmetic, okay? And so we can go ahead with our TN formula for arithmetic. And they've stated here that the third term is 23, and the 26th term is 230, okay? With a question like this, grade 12, start by writing down what's obvious, okay? What's obvious? Term 3, the third term, is equal to 23. And the 26th term is 230. So term 26 is giving us 230. Okay. Here's the part that is important. We've got to now be able to take what's written over there, and we need to create an equation out of it, okay? Now, bearing in mind, our TN formula for arithmetic sequences is a plus n minus 1 d. If I'm talking about the third term, all right, do you guys agree that I could take term 3 and I could write it as a plus, if n is 3, 3 minus 1 is 2. So I'm going to write term 3 as a plus 2d. And I'm going to take term 26 and I'm going to write that as a plus 25d. Okay? Do you guys all see where we get that? All right. Now that we've got that, we've got, would you agree, 2 equations to solve where I'm going to solve for the a and I'm going to solve for the d. Okay, so we've got a simultaneous equation. Term 3 was the value of 23. So equation 1 is going to look like this. We're going to say 23 is equal to a plus 2d. That's going to be equation 1. And equation 2 is going to be 230, which is equal to a plus 25d. And that's going to be equation 2. All right? When we're doing a simultaneous equation, we've got 2 ways in which we can do it. Okay? We can either, if it's simple, if the equations are not very difficult, we can do our elimination method. If they're a bit more complicated, you're probably wanting to use your substitution method, okay? Because both of my a values are just plain a's, what I would say to you is the elimination method over here is going to be nice and easy, okay? And for the elimination method, we are going to take equation 1, and we're basically going to minus equation 2 from it, okay? That's going to give us 23a plus 2d, and I'm going to subtract 230, which is equal to a plus 25d. And when we subtracted those from each other, 23 minus 230.
Hold on, give me 1 second, sorry.
23 minus 230 is going to leave us with a negative, and I'm going to have
30, and it's going to be negative 207.
207.
Sorry, Tamlin.
Thank
I'm
you.
sitting chatting here,
My
not
a's
listening.
are going to cancel out. Positive a minus a is going to cancel out, and if I've got 2 minus 25, that is going to leave us with negative 23. Now what we need to work out is, can we take 207 and divide it by 23?
So what was that again? Sorry?
207 divided by
200
23.
Divided by 23. 9.
9, so
Yes.
it works out perfectly. Right, so 9, the negatives cancelled each other out, so 9 is our common difference. Okay, right, so we've solved for D. Now what we need to do is still solve for A, okay? When we're substituting back into either equation 1 or equation 2, make your lives easier. You don't need to sub it into the more difficult one. Choose the easier equation. And I'm sure you'll all agree with me that equation 1 was our easier equation. So what we're going to do is we are going to substitute the value of 9, which is equal to D, into your equation 1. All right? Okay, now that therefore we've got the equation of 23, which is equal to a plus, and that's going to be 2 times by my difference now, which is 9. Okay, so we've got 23, which is equal to a plus 18, and if I take that over, okay, let's just do our maths over here. 23 minus 10 is going to be 13, and 13 minus 8 is going to leave us with 5 as your value for A.
Fantastic. How about we take a little break?
Super. We'll see you after the
Okay,
break.
guys, I know that you're all probably sitting watching Learn Extra Live in your pajamas, so maybe now is time for a cup of tea since it's so cold outside there. And just in case you have forgotten, which I'm sure none of you have, if you call in, you can win one of these awesome winter school guides. It's full of examples. You can work through it during winter school in July. It's really, really awesome. And let me just see if I can find this number for you quickly. Okay, guys, it's 086 105 58262. So if you give us a call. We've got people manning the back, teachers. So if you've got your maths questions, please give them a call, and you could win 2 awesome books for winter school. So let's take a break, and we'll see you back in 2 seconds. Bye. Hi, grade 12 Mindsetters. So glad you are back. We are having such an awesome session. I see that Kashifa has just seen that we are actually live on a Saturday. It is true. I know sometimes Saturday school comes on and you think that it is a repeat. This is not a repeat. I repeat, this is not a repeat unless they're repeating it. Then hopefully they'll put a little repeat thing. But guys, Saturday the 9th of June, we are now live, and this is Saturday school. I know that Palesa has phoned in and has asked a question. She has gotten 2 books, and that's how easy it was, guys. All you have to do is you have to phone in, and that's how you will get the books. And the number is 086 105 8262. Also chat to me, Indy, on Twitter. It's facebook.com/learnextra. I'm also on Twitter @learnextra, and that's an XTRA. And guys, I have miraculously changed Tamlin into E.T. Watch this magic, okay? And we're about to start with the session, and changed.
It's E.T. I've transformed.
You've
It's a
transformed.
transformation from,
It's amazing.
Exactly. All right. You want me to take off?
Take it off.
All right. My question. Okay, it's not this one actually. Something has happened there. Tanja?
Have you lost the question, E.T.?
Yes, I actually didn't even.
Don't worry. You keep
All right,
looking. Oh, you've got it.
No, I will rather. I remember it very well.
Okay, you carry on
Okay.
looking for it. I can carry on
I will
talking.
rewrite it. The question was adapted from the 2008 paper,
Yeah.
right? It says, if I pick a pen there, x to the 4 plus 1 divided by x to the exponent 4. And, all right, I think it says equals to 1 over 2. And the question says, explain why that the left-hand side will never be equal to the right-hand side. Okay, trying to recall all of it. Okay, so what you do therefore is, okay, recall a few rules about exponents. Think about exponents that are to the even number or to the odd number. Now, whenever you have an exponent that is to an even number, it does not matter. By that I mean we could be dealing with minus 2 raised to the exponent 1, let's say, or that's an odd number exponent in this case. And if I had minus 2 to the exponent 2, look what the outcome is. Because there is only one negative, you get minus 2 there. And on this side, this is minus 2 times minus 2. Whenever you have an even number as an exponent, and you've got a negative base, your result is positive. Okay, so the result here is positive 4. So this is typically an odd number. If it was to the exponent 3, the answer would be negative. If it was to the exponent 4 or 6, so on and so on. Now, when you look at this problem, let's take it down a bit here. Okay, extend this. All right. So what you have is that x to the 4 could be divided by x to the 4. In other words, you distribute the denominator to the two terms above the division line. And the other one was 1 over x to the exponent 4. This is just looking at the left-hand side. And the results that we get just from looking at the left-hand side is that x over 4 divided by x over 4, that will cancel out. That goes once there, and it goes once there. So the result on the left-hand side, if I may write it here, left-hand side equals to that. So what you have is that this is 1 plus x to the exponent 4. Whichever value of x you pick to substitute in that second term of this result, it will be positive. Therefore, it's increasing your result from being equal to 1 to being more than 1. Because whether it's negative or positive, you're going to get plus half or plus 1 over 8 or something like that. All of it is greater than 1. What did we say? We said that the left-hand side must be equal to half. It is impossible because already the left-hand side is greater than 1, and there is no chance of that reducing to anything less than 1, because half on the right-hand side is actually less than 1. So for that reason, this equation has no real roots. Okay. Then you can say the equation has no real roots. Okay, so no real roots means no real solution. In other words, no x values will satisfy that equation. All right, yeah, I will move to the second question.
Let's do it.
Like I said, I've lost the page, so I'll have to
Have a look at the
put it
bottom.
back.
Have a look at the bottom tabs. The producers have told me that that's where it could be.
All right.
So you have a look, but in the meantime, this is my time to shine and be able to chat to the learners.
All right.
Okay, guys, I see that Sepo, you have a question. I will be asking either E.T. to answer it a little bit later, so please hang in there. Utsile, I just want to quickly read her post.
It's not in the list.
It's not in, is it not in the bottom, E.T.?
Yes, I've clicked all of them. It's
Okay,
not
what
in
we'll
the
do
list.
is we'll go to an ad break, but what I'm going to first do is read Otsile's thing,
Yes.
her post, because it's very cool.
Okay.
She says, wow, you live on a Saturday. You guys are really helping, hey. If South Africa doesn't get a high matric pass rate this year,
Yeah.
then she doesn't know. So
Wow.
she's extremely grateful that
She's so right.
she's so right.
Yes.
So guys, what I want Otsile to do, and everyone else that is watching, guys, every matric that you know, phone them right now. If they're still in bed and they're sleeping, they need to be up. You've got 1 year, let's just do this. So by the time prelims comes, you get your prelims with flying colors, and then you can relax for finals, because you know that you're only going to do better and better and better. And we are here, Mindset Learn, to help you along the way. So without further ado, we're going to take a quick break. You can go and phone all of your friends and tell them to wake up live. Not winter school. Saturday school is live on right now. See you
Right
now after the break. Hi grade 12s and welcome back to Learn Extra Live Saturday School. And yes, we are live. Can you believe it? Grade 12s, we've done this especially for you. And also not only are the shows, they're not 1 hour, they're an hour and a half. You guys wanted more time, so that's exactly what we've done. We've given you more time. So now this lesson is an hour and a half, and that's more time to learn more and learn extra. So guys, please chat to me on Facebook, facebook.com/learn extra. I'm also on Twitter @learnextra. And don't forget, if you post your questions and also if you phone in to that number, you will get 2 winter school guides and that you can work through winter school, which is coming up at the end of June. And I just want to read through. We've got maths lit, we've got accounting, we've got English, we've got physical science, geography, mathematics, and life science. So you're going to get maths if you call in, and then any other winter school guide of your choice. And without further ado, I'm going to hand you back to E.T. And we have found the questions, and we are ready to learn more, and we're ready to learn extra. E.T., take it away.
Okay, indeed. Yes, this was actually the first question I was supposed to do, but let me go straight into it. Okay, it says given x is equal to, let me read it in triples. It says 999. Determine the exact value of x squared minus 4 divided by x minus 2. What I always say to my learners is, if I tell you to come across the river to come and get some food, and I don't tell you how to do it, so you must remember that some of you have learned how to swim, some of you have done long jump, and some of you will just say, you know what, I'll go to the shallowest place and cross right across the river. And in this case, I'm not telling you to simplify, but look at this expression. It's you want to substitute x, but as it is, it's just going to be a very big number, as you can see. So the best thing is to simplify this expression first. All right, so if we start off, okay, let me extend this page, and right away, you've got an expression that says x squared minus 4 over x minus 2. What you notice is the numerator of this expression is actually the difference between 2 squares. So this is how you're going to factorize. You're going to say x plus 2 multiplied by x minus 2. This is all divided by x minus 2. Anyone can see that there's something common in the numerator and the denominator, and when you get that, you cancel out. X minus 2 goes once there, and x minus 2 once there. So now you're left with something that says this expression, complicated as it looks, all that could have been written is just x plus 2. Now that you know the value of x, you simply substitute that, and I think we had, okay, now x plus 2 will be equal to, I think we had 999, it was 4 times. Trying to remember this number quickly. And to that we just add 2. Okay? And the answer is simply going to be, if you add 2 to 9, you are going to get 1. So simply this is going to be extended by 1 there. How many? 1, 2, 3, 4. To that I just add a 1. Is that right? Yeah. Am I missing a 0? Let's see. 3, 3, 3, 3. Okay. Yeah, that should be fine. I think we're missing a 0. So I would put, this should actually be 10,000. You know, you have to think of how to read that number. It's quite huge, you know.
It's a huge
this
number.
This is one of those we say milliards and millions.
Millions and trillions.
Yeah.
10,
Okay.
yeah.
So I'm not going to get into that, but yeah, there is your simple answer to that question. Okay, so remember what I said? When you're given an expression, you're not always going to be told that, to be requested to simplify. You've been given all the tools, you must simplify to whatever simple form you can get. Okay. All right. And I'm going to move to the next question. All right. Okay, that question, it was over there. I think a caller gave us this question.
Yes,
And,
yes. Palesa, I think her name was.
I'm not sure if it's Palisa, but the caller said we must find the derivative.
Yes.
What I don't know is whether it's from first principle or you know, using the rule. But I'll use the rules. I'll use the rules. This expression, as it is, we could have given it a name. Or let's say this is y equals to that. Okay, so whenever we talk about the derivative, we're basically talking about the change in y over the change in x. And we're going to write it as dy dx. That's what we're being asked to find. This expression as it is, again, it looks very complicated. It could be that it's a very simple expression. Let's just simplify it. It's actually, if we divide, we take this denominator and distribute it to the terms above the division line. So we're going to have x to the exponent 3 divided by x to the exponent 2, and we subtract x to the exponent 2 over x to the exponent 2. Suddenly, this expression is actually the rules of exponents now. X to the exponent, if you have a common base like x and x, you are going to subtract the exponents. So it's going to be x to the exponent 3 minus 2. So you will have x to the exponent 3 minus 2, which is 1, and you subtract, in this case, x to the 2 divided by x to the 2. Those things are alike. You can simply cancel out. All right. This is now in the way. Minimum. Okay, where is it? Yeah, there. This thing doesn't minimize, and
Okay, guys.
it's frustrating me now.
Don't worry. You try sort that out, and I'll chat to the learners. Mindsetters, don't forget that we are giving away these awesome books, and all you have to do is phone and you get them. That's it. And just
does not respond.
It's not responding. Producer, I think what we should do is take a little break. E.T. Hey, I think maybe it's the best. Guys, we'll be back.
Let's do that.
Please don't forget to post all of your questions. And even if you can't phone, I know some of you are saying that you don't have airtime to phone, you can still post your questions on the page and we will still answer them. So guys, please keep posting those questions and we'll see you now after the break. Hi guys, we are back and E.T. is going to be finishing the question that he is on. Don't forget to keep those questions coming, and if your friends are sleeping, it's time for them to wake up. Phone them, text them, let them know that Saturday school is on and it is live and we are taking all of your questions. E.T., time to carry on.
I'm going to carry on. The board hopefully won't misbehave now.
Hopefully, else you're going to have to shout at it.
Won't misbehave.
You shout at it, E.T.
All right. I carry on from where I left. I think I was still explaining how this expression can be simplified into this form. Now, the x squared simply cancels out there, and you're left with 1 there. Straightforward question. Now, we're actually asking you to just find the derivative of that simple function, x minus 1. And if I use the rule, that is going to be equal to this is x to the exponent 1. So what you do is take 1 to the front and then subtract there. Now, the rule says if you have your function as x to the n, then your derivative function is going to be n x to the exponent n minus 1. So I'm applying the rule crudely as it is. And if you have a constant, now that's going to be minus. Now this is to the exponent 0. Any number, raised to the exponent 0 is 1 anyway. So suddenly we are going to bring the 0 up front. So because that's what this rule demands. So if you bring 0 to the front, all right. Okay. Indy?
What's going on now?
There goes again.
Is it doing it again?
There goes again. I mean, I was standing here and this thing disappeared in front of me, but I got it back.
You got it back, hey? Like magic.
So over there, if you then, okay, let's just make a line here to separate the two. Okay, there's pen. All right, so the other part of this expression is that you are now going to do a derivative of a constant. So which means you put a 0 in front and you multiply by 1 to the exponent 0 minus 1. So essentially, this is 0 anyway. So you will now learn that as long as you have a constant, you are going to, when you find the derivative, you are going to get, it's going to be equal to 0. Okay, so 0 times anything is 0. So our answer to this question is simply 1. 1x to the exponent 0. Okay, let me just extend it a bit, which is basically equals to 1. All right, and I think that's the question that came up. Yeah, that's time for a break.
Okay,
Let's
guys,
yeah.
it is time to take a break. When you get back, E.T. will be magically transformed into Tamlin. Make sure that you get some tea because it is cold today, guys. Please let me know what part of the country you are watching from. And let me know, is it as freezing as it is in Joburg? Because I'm cold. See you now after the break. Hi guys and welcome back. I hope you've really been enjoying the show, and Tamlin is back, so she'll be answering your next question. Please make sure that you do post your questions to facebook.com/learnextra. Also chat to us on Twitter @learnextra. I have told you guys about the books, so I'm not going to tell you again, but also what I do want to tell you is that they are available for download free from our website. So if you don't win a book, I am going to post the link to our website where you can actually download it and print it for free. You can actually also buy them from our shop, and I'll also post the link to that, and they are 10 Rand each, guys. And special orders, if you order more than 500, so maybe your books, your school will order them, then delivery is free. So without further ado, I don't want to take any more away from your lesson. I'm going to hand you over to Tamlin. Take it away.
Thank you, Indy. Right, we've had a call from, is it Katlejo?
Yeah.
Right, we've had a call from Katlejo, and this is the question that we have got from him. Do we have Katlejo on the line?
Yes, hi.
Hi there, how are you?
Fine, thanks for you.
Good, fine, thanks. Okay, Katlejo, if I'm correct, this is the question that you had for us earlier, where you said that you had a sequence of 4, 9, x, and 37, and you were told in the question that it's a quadratic sequence. Am I correct? Okay, right, okay. This is what you need to take note of, Katlego. If you have got a quadratic sequence, if you can remember, a quadratic sequence is defined by the fact that you have got a second common difference. Okay, now what that means is that if you have got a first common difference, let's just get our pen. If we've got a first common difference, the way that we're going to work that out is we're going to take term 2 and we're going to minus term 1 from it. Okay, term 2 minus term 1 in this case gave us 5. I'm then taking term 3 minus term 2. Now that's going to give us x minus 9. And then I've got term 4 minus term 3, which is going to give us 37 minus x. Okay, that's the first common difference. Quadratic number sequences have got a second common difference, so we need to do this one step further. I now need to take the difference between those two terms. So I'm going to say x minus, and I'm going to subtract 5 from it, okay? And let's just simplify that quickly. That's going to land up giving us x minus 14 over there. And if I take this term minus this term, we're going to have 37 minus x, and I'm going to subtract. Now, can you see I'm putting in this in a bracket? We're subtracting x minus 9 from it. The reason why I'm putting that in a bracket, please be careful, because the negative must distribute into that bracket, into both the terms. Okay, Katlego, so now what we're going to do is let's just simplify this out over here. So I've got 37 minus x, and when I distribute the negative, we'll have negative x there, and we will have plus 9. And if we just quickly tidy that up, we are going to land up with 37 plus 9, which is going to give us 46, and I have got minus 2x. Okay. So what we've done so far is we found a first common difference. From there, we found our second common difference. The reason why we did that, because we were told it's quadratic, okay? And what we know about quadratic is that those second common differences are equal. So what you now are allowed to do is take this common difference, and we are basically going to make it equal to that common difference, okay? So therefore, what we are going to say is x minus 14, we are now going to make equal to 46 minus 2x. Okay, are you with me there?
Yes.
Okay, so what we're now going to do is just solve the equation. I'm going to bring x over to, or 2x, negative 2x, onto this side. So therefore, we're going to land up with x plus 2x on the left-hand side. And I'm going to have 46, and I'm going to have plus 14 on the right-hand side. Okay, when we add our x's, we're going to have 3x on this side, and when I've got 46 plus 14, we land up with 60. And when we divide by 3, we land up with our value for x that was missing, and that was 20. Okay, Katlego, do you understand that?
Yes, now that I get it, yeah, now I get it.
Fantastic. You've just got to remember, if they're talking about a quadratic number sequence, that second common difference is the crucial thing to remember. So you find your first common difference, you find your second common difference, and then from there, once you've done that, if we're trying to find the missing variable like we have over here, that is what you're going to have to do, is make those two second common differences equal to each other. All right.
Okay, thank you.
Super. Thanks so much for your call.
Okay, thank you.
Bye-bye.
It's so nice talking to the mindsetters.
Yes, yeah, they
I
have a
love
lot of
it.
good
It's
questions.
awesome. Thanks for phoning, Katlego.
They have a lot of good questions.
Yeah.
Right, what we can do, just to help Katlego reinforce what it is that she's actually just asked us, is we have a similar question. So let's just find it on our board. Okay, we'll actually do that in a minute. What I want to actually have a look at over here is also a sequences and series question, but also a very common type of question that they ask you in exams. Obviously, they're not always going to make your life easy. They're not always going to make it just arithmetic or just geometric. What they sometimes like to do is to mix them together. Okay, so this is quite a nice example that we can have a look at where you would see this happening. Okay, so in your exam, this is the question. They've said, consider the sequence 1, 3, 2, 9, 3, 27. Now, at first glance, this seems very weird. Some of the terms are up, some of them are down. If we just look at it as the sequence is not following much of a pattern for us, okay? So this is where you've got to be careful. What we are going to do is we're going to look at every alternate number in the sequence, okay? So please remember that, grade 12s. If you're sitting with a sequence which is just not making sense to you, okay? the values are not following from one term to the other. Please look at that every second term, because what you may just find is that every second term is forming a particular sequence, and then the alternate terms on that are forming another sequence, okay? So let's see what we've got over here. If I look at my alternate terms, my every second term, I've got 1, I've got 2, I've got 3, and then we didn't know the next term. Okay, so suddenly that looks like a little something that's a bit more familiar. And if I look at the next sequence over here, I've got 3, I've got 9, and then I've got 27. Okay, so do you guys agree that once I've separated those alternate terms, I actually have two quite recognizable sequences? The first one is going to be an arithmetic sequence where I've got a common difference of 1. So from term 1 to term 2, and from term 2 to term 3, there's a common difference of 1 each time. And in my second sequence, if I go from term 1 to term 2, this time I didn't add anything, I multiplied. So I had to times it by 3 to get from 3 to 9, and to get from 9 to 27, I multiplied it by 3 again. Okay, so we've got them. We've now figured out that we've got an arithmetic sequence and we have got a geometric sequence. You see, they never make these things easy for us to figure out.
Never, never.
Okay, so what they are asking us to do is to write down the next two terms in the sequence. Okay, from this is really just by inspection. You're just going to look at it and there's no working out required here. You're just going to have to fill them in. So looking at my values, I've got 1, 2, 3. I'm sure everybody would agree the next term in that sequence would be 4. And if we've got 3, 9, 27, the next term in that sequence is going to be 81. Okay. Right, so question A answered. Question B, they are now looking for the sum of the first 32 terms. Okay. Bear in mind, grade 12s, that half of the sequence has been made up of an arithmetic sequence, and half of it has been made up of a geometric sequence. So does everyone agree that the arithmetic sequence is making up 16 of the 32 terms, and the geometric is making up 16 of the 32 terms? So when we're doing our sum, our SN formula, for each of them we're going to have to work out the sum of 16. Okay. Right, so let's look at our first one. We had the sequence of 1, 2, 3, 4. And we're looking for the sum of the first 16 terms of that sequence. Okay, so therefore what we're going to say is I've got n over 2, we've got 2a plus n minus 1d. Remember, that is our SN, our series formula. Right, what do we have? I've got a, which is my first term. My common difference is just 1, so let's go ahead and fill this all in. So the sum of the first 16 terms is going to be equal to 16 over 2 multiplied by 2 times 1 plus, okay, 16 minus 1 is going to work out to be 15. And the common difference from every term, from one term to the next, there is just 1, okay? Right, so let's simplify this out now. 16 divided by 2 is 8. 2 times 1 is 2. 15 times 1 is 15. We've got 8, and we've got 15 plus 2, which is 17. And we now have our calculator here, so let's say 8 times by 17. And that gives us 136. Okay. Right, so 136 is the answer that we have over there. Okay. But again, bearing in mind that that's the sum of the first 16 terms. Right, that's the arithmetic part of it. Let's do the geometric part of it. Geometric, the formula, the sequence was 1, was 3, it was 9, it was 27. Okay, so we're looking for the sum of the 16 terms over there. Right, a formula that we haven't worked with yet is our geometric SN formula. Okay, this one over here is going to be a multiplied by r to the n minus 1 over r to the r minus 1. Grade 12, your teachers may have taught you that there's two ways in which to write this. You can either write it as r to the n minus 1 over r minus 1, or you can do it the other way around. We can write it as 1 minus r to the n over 1 minus r. The difference really is just depends on what your common ratio is, okay? If you're sitting with a common ratio bigger than 1, it's going to be better to have your r as the first term in your bracket. It's going to avoid us having to work with any negatives, okay? And if you have a common ratio less than 1, then do it the other way around where your common ratio is behind the 1. Okay, right, so because our common ratio was 3, we chose to use the formula like this. My first term in this sequence was 3. My common ratio is 3. I'm raising it to the power of 16 minus 1. And this is over 16 minus 1, which I'm sure you'll agree with me is 15. Okay. Right, at this stage, calculator's out. All right, we're going to type this in. So let's clear it out and let's say, okay, I'm going to use my fraction button over here. It's going to make life a lot easier. And we've got 3 brackets. I've got 3 to the power of 16 minus 1, close your brackets, go down to the denominator, and it's over 15. Right, we land up with 8,609,344. Right, okay. So we've got a rather large value over there. Oh, and I've lost it. 8,609,344. 8,609,344.
8, 6,
Okay.
0, 9, 3, 4, 4.
Okay.
I'm even remembering it. I'm like, oh.
Right. Now what we've done is we found the sum of each of the sequences or the series individually. So the last thing for you to now do to answer the question in total is if they wanted the sum of all 32 terms, you're going to take the sum of the geometric sequence, the nice big answer over here, and we're going to add the sum that we got of our arithmetic sequence, which was 136. Okay, and when we add those together, if I add 136 to my answer, we're going to land up now with 860,9480. 860. Indeed, you remember?
Oh my gosh, I
Okay,
don't.
that's fine. 860,9480. Right, 9480.
If you need me to remember a number,
Sorry, I have to tell
you
you.
can rely on me. Sometimes I'm too busy typing away, so just go.
All right, grade 12. So just take note of a question like that. It's very common. It's the type of thing that comes up quite often. The way you're going to identify it, once again, is if you've got this sequence which is a little bit all over the place, the terms are not seeming to follow in any kind of order, then take a look at every alternate term in your sequence and you may just find the solution to that problem. All right. Okay, do we have time for another example?
I think we do. Let's do another
All right.
example.
Right, I think now let's have a look at a bit of sigma. Okay, good old sigma, surely there to come up in your exam. And what I'm actually going to do quickly is refer to a sigma. We're going to incorporate sigma with also a little bit of sum to infinity. Okay. Right, when you see a sigma sum in your exam, all right, you can really rely on 3 steps to get you through this. Okay, so we're going to say step 1. All right, with your sigma, what we're sitting with over here is at the top is representing the number of terms that we are adding up. Okay, at the bottom represents a value for p, and that we substitute into our Tn formula, our nth term formula over there. And step number 1 is going to be this. We're going to take that little value down at the bottom. Whether it be 1 or 2 or 3, it actually doesn't matter. You start with what the value is down at the bottom over there. And you substitute that into the variable, or into that variable in your nth term equation. Right, so starting with 1, we're going to have 8 times by 4, and I've got 1 minus 1. That's going to leave us with 8 times by 4 to the naught, and is everybody happy that that is going to work out to be just 8? Okay. Right, that is going to be term 1. Term 2, I'm now going to do the same formula, and I'm going to substitute 2 into the equation. All right. So when we work this out, I'm going to have 8 times by 4. This is going to work out to now be negative 1. All right. Negative exponents, the way we can typically deal with those is we can bring it down to the bottom. We can invert that, okay? And we lose the negative exponents. And that works out quite nicely because your 4 cancels with your 8 twice. So now we're sitting with a second term of 2. And finally, we need a third term here. So we're going to take the same equation and we're going to substitute 3 into it. So we're going to have 8. I've got 4. We've got 1 minus 3. That's going to leave us with 8 times by 4 to the negative 2. I'm now sitting with 8 multiplied by 1 over 16. And that will then land up giving us 8, which goes into 16 twice. So we're getting a half. Okay. All right, so step 1, you're substituting the value down at the bottom of your sigma into your equation, starting with 1. And as I said, even if the number down at the bottom is 3, start with 3. And then you just do each consecutive number after that, okay? So because we had 1 at the bottom of our sigma, we're going to start, we started with 1, then we substituted 2, and then we substituted 3, okay? And that gave us the first 3 terms of our sequence. So term 1 worked out to be 8. Term 2 worked out to be 2. And term 3 worked out to be a half. All right. Okay. So now that we've got that, we've done step 1. All right. Now, obviously, by the fact that we're working out a sum to infinity means it's got to be geometric. Okay. There's no doubt about that. If you weren't sure, however, we go back to our test. We do our term 2 minus term 1. See if that's equal to term 3 minus term 2. If it's not, we test for geometric. As I say, because it's infinity grade 12, you know that it's going to be geometric. Okay. So
Tamlin, can I ask a quick question?
Yes.
It was in class, asks, let me have a look over here. It says, please ask, where does the 15 on the denominator of the geometric come from?
The 15.
Yes.
Let's just see. Oh, this one over here?
Yes.
Okay, it's not 15, it's 16.
Is it 16?
So let me rewrite it over here, that's fine. Okay, so what we had was, we had 8 and we had 4 to the negative 2. Okay, all right, sorry, I skipped a step.
Oh, shit.
What I did was, if you have got a negative exponent, the way we get rid of that negative exponent is you bring your value down to the bottom of a fraction. So instead of working with 4 to the negative 2, I'm going to work with it as 1 over 4, but then that becomes positive 2. Okay? Now, 4 squared is 16. So if I have got 8, and I've got 1 over 16, that one's disappeared. That's where the 16 came from. Okay. All right. So, and then what we did is we said that 8 went into 16 twice. All right.
Ah, perfect. Thank you. I'm sorry for interrupting.
No, that's absolutely fine. Sorry, skipping steps. Right. So let's work out. If I take term 2 and I divide it by term 1, okay, that is going to work out giving us 1 over 4. If I take term 3, which is a half, and I divide it by term 2, which is 2, okay? The working out here is that we need to do a bit of a tip and times equation. If you want me to show the working out, we can do that. That would be a half. Instead of saying divide by 2, I'm going to say times by 1 over 2, all right? And as a result, you see that our common ratio is a quarter. Okay, so, right, step 1, we found our first 3 terms. Step 2, I've now calculated my common ratio, and by default, we've worked out term 1, so we know what A is, okay. Right, term 3 is now sigma represents sum of. So with sigma, you are always using your SN formula, okay, that is a done deal. And what we're looking for now is the sum to infinity. Sum to infinity is going to be our A over 1 minus R. When we're working with sum to infinity with a geometric sequence, what we have got to have, it's a funny word, but we've got to have something called a converging series, okay? Now, in plain language, a converging series basically means that your common ratio has got to be a fraction, okay? If it's any whole number, your series is then what we call diverging, and we cannot work it out to sum to infinity. Okay, so therefore, do we have a common ratio that was a fraction? We do. It was a quarter. So please check that, grade 12s. When you're doing your sum to infinity, it's got to be converging, and that's between -1 and +1. Fraction. Okay. Right, so now what we've got is sum to infinity, which was equal to our first term, which we worked out was 8. So I've got 8 over 1 minus, and my common ratio is a quarter. Okay? With that, we can say that I've got 8 over, if I took 1 whole and I minused a quarter from it, we are going to land up with 3/4. And instead of taking 8 and dividing it by a fraction, let's rather tip and times it. So we're going to say 8 times by 4 over 3. Okay, 8 times 4 is 32, and we divide that by 3, and we could say, what have we got here? That that's going to be 3 into 32 is going to go in 10 times with 2/3 remaining. So my sum to infinity is going to be 10 and 2/3. Please remember, sum to infinity must be converging, and converging essentially means your common ratio must be a fraction. And if you remember that, sum to infinity is easy. Okay. Right, how are we doing, Indy?
Let's take an ad break. I
Super.
think we need a bit of an ad break. I can take a little stretch. I think now it is 9 minutes past 10. Surely you should all be up by now. I do see on Twitter that we've got a little thing going. Let me just have, I think it is Limpo. I don't know who actually started it, but you guys are calling grades 12s to wake up, get up and watch Learn Extra, which is awesome. So guys, let's take a little break, give yourself a little stretch, and we'll see you now. Hi guys, and welcome back. We are entering the last few minutes of our Maths Learn Extra Live Saturday show, and E.T. is back with us, and he will be taking us through right to the end. Guys, now is your chance to get those questions in, to learn more and to learn extra. And if your friends aren't awake, wake them up, because Physical Sciences is on next. Chat to me on Twitter and Facebook. That's at Learn Extra for Twitter, and facebook.com/Learn Extra for Facebook. Okay, E.T., take it away.
Thank you, Inda. Many questions have streamed in, and I've got two that I'm going to do. The first one, I think it was Palisa's question. She said m and n are rational numbers, given that the square root of m plus the square root of n equal to square root of 7 plus square root of 8. All right. And calculate the possible values for m squared plus n squared. All right. So by looking at the equation itself, the left-hand side and the right-hand side, you will see that m and n sort of correspond with the 7 and 8 by deduction. By deduction, your m, if I take my pen there, all right, my m equal to 7, and my n is equal to 8. You could have swapped that around. Okay. Now, what happens is, it's a very straightforward question. All you have to do is square the m and square the n and add the two together. All right? So if I say m squared plus n squared, I'm going to get 7 squared plus 8 squared. And that comes to 49 plus 64. All right? And 49 plus 64, that should be 113. Yes. So the result of this is just 113. Believe me or not, it's that short. Just because we deduced the fact that m and n are rational numbers, therefore 7 and 8 are actual rational numbers. So we picked it from that. All right, the next question that I have, right, it says find from first principle the derivative of y equals to 1 divided by 8x cubed. All right, so if I give this a name, okay, a name and say f of x equals to 1 over 8 x to the exponent 3, right? Now, from first principle, if I can just bring back the definition before we even get to the next step. The definition says your first derivative is equal to the limit as h approaches 0 of your gradient, and your gradient is represented by that, the gradient of your tangent to the curve, f of x, that is divided by h. Okay, so we're working toward that. So if we already have f of x, we can now find f of x plus h. F of x plus h will be 1 over, where we see x, we will now put x plus h. And that is to the exponent 3 down there. All right? Take it one step further. So we were required to find, according to the basic definition for first principle, to get f of x plus 8, subtract f of x. So I'm going to write that conveniently here before I put this, all of this back into the definition. X plus h, take away f of x. Let's see what that gives us. So we've got 1 over 8 x to the 3 minus 1 over, oh, this is supposed to be, in bracket, x plus h to the 3. We take away 1 over 8 x to the exponent 3. Okay, so if you look at that, you have 1 over 8 on both terms, and you can actually take it out as a common factor. And that comes out to be 1 over 8 into 1 over x plus h to the exponent 3 minus 1 over x to the exponent 3. All right. Okay, so at that point in time, you are dealing with fractions inside the square brackets there. So if you are going to add fractions, the best thing is to make sure that they have the same denominator. That's what gives a name to a fraction. At the moment, you've got x plus h to the exponent 3, and the other side is x to the 3. And the LCM for these two terms inside the square bracket will be, if I can just write it here as a reminder, my LCM or LCD, because I'm going to make it the denominator, will be x to the 3 into x plus h raised to the exponent 3. Okay, so that's just my small note there. And if I proceed, basically I'm wanting to make the denominators to be the same. For this part of the two terms, let's just rewrite this here. I will have, yes, I will have the x plus h to the exponent 3 and the 1 there, but I need to introduce x to the exponent 3 to this, and I just do that by putting in a unit identity, because any number over itself is equal to 1. So I just multiply it by 1. So I subtract 1 over x to the exponent 3, and I need another unit identity there, which is going to be x plus h there, this are cubed. Okay, then I can close my square bracket there. All right, so what you see therefore from here is that they have the same name because they both have x to the 3 and x plus h to the exponent 3. So now you can write this thing as 1 over 8. Inside there you can put x to the 3 into x plus h to the exponent 3, and at the top what you have is x to the 3 minus x plus h to the exponent 3. Right, now you're faced with, the bottom is fine as it is, but at the top you've got x plus h all to the exponent 3. Now you have to multiply out all those factors. And what can help us quickly here, I would like you to take this to your bank of knowledge here. When you must have heard about the Pascal triangle, which says the coefficients of your terms, if you are multiplying out a binomial, in this case our binomial is x plus h, and it's raised to the exponent 3. So this would be corresponding to n equal to 0, n equals to 1, n equals to 2, for n equals to 3. if this exponent was to the exponent n. For n equal to 3, it would be 1, 3, 3, 1. You are going to quickly then, to multiply that out, you're going to have, okay, let's rewrite the rest of this. So it's x to the 3, you take away, now this is going to be x to the 3 plus 3x squared h plus 3x h squared. To that you add h to the exponent 3. All right, that would have to be divided by what you have at the bottom. X to the 3 into x plus 8 to the exponent 3. All right, so let's extend the board and get some more space. I think right more to the left, because it keeps constraining me on the right there. So you've got 1 over 8 into. So what you'll notice is that when you open this bracket, there will be the x cubed that cancels out the x cubed. And what you have in the bracket there is simply multiplied by minus. So minus 3. In fact, you will notice that everything has got h over there. So you can already take the common factor of h. Okay. Okay, 3x squared. 3x squared h plus 3, oh, it will be minus now, minus 3x h squared, then you have h to the 3 there. Then you divide the whole thing by x to the 3 plus, times x plus h to the exponent 3. All right. Right? Now, what you can see at the top is that h is running through all the 3 terms that remain at the top. So you take out h, now you have got 1 over 8. You take out h there. By the way, this is supposed to be minus there. Okay. And what you have is that this is minus, and there is a h that you could have taken out. Then that is 3x squared minus 3x h, then you have minus h squared. Right, x to the 3 into x plus h to the exponent 3. Okay, there you go. This is an expression that you will need to put back into the definition. And by the way, in the definition, you've got h at the bottom. So when you put this in, your dy dx comes out to be the limit as h approaches 0 of this expression divided by h. And I can write the h out there, and inside I simply put the whole of this expression. Minus h into 3x squared minus, plus 3x plus h. Where is that? Yeah. H is out already, xh here, then h squared there. All right. So that's divided by x to the 3 into x plus h to the exponent 3. Right. So we are right at the end of the problem, because the h will cancel the h, and what you're saying is as h approaches 0, basically some terms will fall out here. And we'll end up with this part with the h falling out, and this part falling out, and that falling out. So then the answer to this is, you simply have minus 3x squared at the top. And where is my 8? The 8 was supposed to still be there, so I'll put it here. So outside of this, you had a minus. Okay, so you still have minus 1 there. So basically I could still keep that outside here. 1 over 8. Then this is on the inside. Minus 3x squared divided by just x to the exponent 4. Then from that point you just cancel out. Okay, minus and minus. All right. So this is once here, and it goes x squared there. All right, this comes out to be minus, I think it's going to be plus, so it's going to be 3 over 8 x squared. I hope I got my signs right there. Okay, but that's the process that you go through to do it, you know, from basic principle, first principle.
Fantastic,
All right.
E.T. Okay, guys, thank you so much for joining us today. Don't forget the Physical Science Grade 12 is on next, and it is going to be an awesome show. Guys, don't forget to keep helping each other. If you do see somebody else is struggling on the page, please help them out. If you understand what their question is, that's what we like to do. We like to help each other out, learning more and learning extra. So, guys, we've got to go. Thanks for joining in. See you same time, same place next week. Maths, next week, Saturday. Bye.